This session's been brilliantly organised. The transition straight from JOS through to rOpenSci is fantastic and was a surprise to both of us. So it's fantastic. I won't presume that everyone was here for the session before, but I hope that most people were, so I won't have to talk too much about the software peer review process, which a walkthrough of JOS just happened. This talk's going to focus a lot more on the community side of things, and particularly, as it says there, on the importance and challenge of community engagement. I'll focus an awful lot on the latter of those, on the challenge. The importance of it, I trust most people will understand. The morning session tomorrow morning here at 9 o'clock is all about the importance of community engagement for research software engineering. Importance, for example, the classic example is I've got a piece of software. At some stage, I can't be bothered, don't want to maintain it anymore, so I write a little thing on my software that says, I'm retiring this software now, I can't do it. And I get a response from a community that says, you can't do that, we want this piece of software, we need it, we love it, can we take over and maintain this piece of software? That's kind of the hallowed heaven of open source software. And that sort of process only happens with really strong community engagement. This talk's going to be all about the challenge of maintaining that kind of, or achieving that kind of level of community engagement. Before I get to that, I do need to talk about some technicalities of the software peer review process. The talk we just had was, or the walkthrough, was from Journal of Open Source Software. Arvon pointed out there that JOS and rOpenSci have worked together very closely throughout the development of the two systems there. The differences between them are primarily, there are a lot of subtle differences, but some of the major ones is that JOS is in effect a journal. At the end you get this published artifact, whereas rOpenSci is also a journal. It doesn't publish a paper in the sense that JOS does, but it has a lot more of a community around it. Or for people who like to think in more metaphoric terms, you could almost say that JOS is like a gateway, traditional to parallel to a more conventional academic publisher, that you walk through the gate and you have your publication on the other side of it, and rOpenSci is more like a doorway into a welcoming community that exists beyond the moment of publication with rOpenSci. These are some of the other activities that rOpenSci engages in beyond just the software peer review. I'll point out one very important one of these, which is the second on that list of multilingual publishing and access. So for example, rOpenSci now operates almost all of our activities completely bilingually in English and Spanish, so anybody can access any of the entry points to rOpenSci, including software peer review, completely in Spanish, have conversations completely in Spanish, and we will process all of that. We haven't yet covered every single entry point, but we've set up a lot of infrastructure for that sort of multilinguality, and now we have an entire volunteer community who are Portuguese speaking, largely from Brazil, as well as from Portugal, and so we're now embarking upon opening another door to multilingual publishing just because of community support. So there's a whole lot of community activities that rOpenSci engages in as well. Back to software peer review. We have, similar to JOS, a guidebook, as we call our dev guide, which is online there. There's also a dev guide for statistical software peer review, which is the focus of the talk today. This is the cover of our dev guide. I won't show you any of the contents of that. But the important thing is the why do software peer review? In a lot of senses, our answers are very similar also to JOS. I'll keep sort of reiterating similarities and differences between rOpenSci and JOS. Basically, you do peer review, or one motivation for people doing peer review is very similar to JOS, that at the end you have this recognized, badged output at the end of it. We get our badges that look like that, the green one there that says rOpenSci peer reviewed, and your software is then seen as a sort of genuine research artifact. But the more community-based side of rOpenSci offers then additional benefits as well, that we, through the way that our community work to support one another as developers. One of the ways that this symbolically happens is that rOpenSci software peer review generally ends with packages then being passed on in GitHub to the rOpenSci organization. JOS doesn't do this. You submit your package to JOS and you get to maintain complete control of it. This was just a decision that was made way back at the outset of the peer review process, and we've had a lot of conversations about potentially changing the implications of it. But one effect that it has is that people then transfer their software to rOpenSci and so engage in this symbolic activity of giving the software over to the community of rOpenSci. And we're convinced that part of that is what's helped build our community. around us. So in short, why submit software to rOpenSci for peer review? We're convinced that it's because you'll build better software with our community. And those two aspects are different and then also sort of synergetic. You build better software through a peer review process, just like JOS improves the quality of software through the peer review process. And you'll build better software with our community as well, the additional support of the rOpenSci community. My one pitch, please submit your software, just like the pitch happened just before for JOS, which leaves everybody here saying, hang on, but should I submit my software to JOS or should I submit my software to rOpenSci? Never fear, the two journals work together. They've worked together throughout their whole development. A lot of the tooling is common. The editorial bot, for example, is shared between us. The development of that has been shared between the two organizations. They work together. rOpenSci is, I haven't even mentioned that yet, but rOpenSci is exclusively focused on the R language, so has a much narrower scope than JOS. If you have an R package, we encourage, and I'm pretty sure that JOS would agree with this statement, to first submit to rOpenSci to go through our peer review process, and then after having gone through rOpenSci to then submit to JOS. That's a very standard procedure that's followed by quite a lot of submissions. So, rOpenSci peer review at the moment is defined by these categories. rOpenSci is also, you can tell by the Sci bit at the end, entirely focused on scientific software. This is an RSE conference. These are the categories that we currently are able to peer review. I won't go into the details of those categories there particularly, but what you will notice is that there's no statistical software listed in those categories. I'll go back just in case. See, there's nothing there that even approaches sort of statistical software, even though we're called rOpenSci and R defines itself as an environment for statistical computing. So this is obviously a grave oversight and something that Noam Ross, the co-presenter of this talk, who's not here today, that troubled him for a lot of years. And so he formulated the idea initially to expand software peer review to include statistical software. And then we graciously got funded by the Alfred P. Sloan Foundation, embarked upon the project, and 2.5 years later, we had our first submission of statistical software. I won't zoom in, but if you can see way up on the top, the badges on the issues there, just like for JOS as well, there's a stats badge, and that was our very first stats badge. So it took 2.5 years from receiving the grant to receiving our first submission of statistical software peer review. I'll go into a bit of detail of the process we had to go through to make that happen in order to understand, not to forget the focus of the talk, the importance of community engagement. So first of all, what we had to do was define what statistical software was. So I'm going to go now into a little bit of technical detail of statistical software review process before I step back out again into the community sort of focus level. So in order to understand or to get a concept of what statistical software is, which means really I needed to read an awful lot of software code, of conference proceedings, of journal articles, and through doing all of that, look for common patterns without even knowing what those patterns might have sort of been. This was quite a long research exercise, generated a whole lot of data. The whole thing was open source the entire time. The links to these slides will be shared after the conference, so that link there anybody can look at, and it's all documented there. This is an example of a full interactive network visualization of statistical terminology and stuff. We used all of that to come up with statistics, with categories of statistical software. And this we used to sort of guide the structure of our statistical software review project. We said these will be the central categories that we will review. We had additional categories that we decided were definitely out of scope, but there were a few categories where we weren't really sure whether they were sufficiently distinct from the empirical basis. There was a lot of back and forthing, but this is where we've ended up with the system at the moment, accept submissions in these 8 categories of statistical software. Okay, so we knew what statistical software was for our purposes. The next question was, how can we assess statistical software? What we wanted to do was to create a system that was as little different to the current software review system as possible, that there was as little friction as possible in adapting to this new system. So how we assess general software for peer review at the moment is effectively that we leave that onto the reviewers. It's the onus of the reviewers to assess the software. We also have a checklist system, just like JOS. Once again, the two systems are very similar in a lot of ways. Our checklist is different. There's a lot of aspects that are very specific to the R language and to the way that R software is packaged up. But the reviewers fill out a whole lot of checklist items, and then they get onto the qualitative content of the actual review. And that is the assessment of the software in the general review process. For statistical software, you wanted a similar thing to happen. But we're also really aware that statistical software is quite unique in a lot of ways, especially through being really, really highly technical quite often in terms of algorithmic implementations and a whole lot of sort of fine details of the nature of statistical algorithms. So what we wanted to do was avoid reviews getting bogged down in these kinds of tiny little details like questions of tolerance or convergence testing and all of these aspects that are really quite unique to statistical software. We wanted to elevate the focus and the tone of reviews beyond these tiny little details. And in order to do that, we needed to sort of dispense with those details to get everyone on sort of a common language or a common way of handling these details. And so we resolved upon the decision that we would assess or the aid to assess statistical software that we would implement would be standardization, to write a set of standards. What we did not do here was there's probably people here who've seen this XKCD little comic about the perils of standards, what you do when one lot of standards doesn't agree with another one, you make up another lot, and at the end you have just more standards. This is not the case of that because there simply were no standards for statistical software at all. So we were the first ones doing this. We were literally making up an entirely new set of standards where none had existed before. And we did this because not only did we think that standards would aid the software review process, but we were convinced that standards themselves, through authors of software having to address them, would improve software quality and aid software maintenance. So then we had to write these standards for statistical software. To go back to the points before of the sort of data input for this project, this looking for common patterns was then extracted out, and from the common patterns, basically we looked for common practices in the design of software, distilled those into sets of good practices and converted those into written standards. And we ended up with this collection of numbers of standards. At the very top, it also includes general standards that all software is expected to comply with. So in total, in all those categories, there are 320 different standards across the 8 categories. What this does, through us requiring authors to fulfill all of these standards, is place a much higher burden on the authors of software when preparing it for review. So statistical software authors have to jump a much higher hurdle than authors of general software submitted to the general review process. And what we didn't want to do was to increase or to place a similarly increased burden on either reviewers or maintainers, but we didn't know anything until the system was up and running about what that burden might potentially be. So what we effectively needed to do was to document and assess standards compliance in a way that best aided both the review process and the maintenance processes of software. I'm not going to talk about this at all in any further detail, but people are very welcome to ask questions later on. But it involved, again, much of this work was done in conjunction with parallel developments in JOS. We developed for our specific statistical program a system to document statistical standards compliance in the code itself, and then to automatically generate reports on standard compliance within the code, and also fed back these automation processes into a more general review system, including also with JOS. And one of the things that we did separately was a much more comprehensive system to automate the checking of both statistical and general software packages when they're first submitted. So you saw the JOS checks before coming up, and ours are sort of all integrated in one place, and it's a much more comprehensive check because we only process our packages. So in short, we used all of these automated processes in order to reduce the burden on our community, the community of authors, of reviewers, of editors, and everybody involved with rOpenSci. So that got us to the stage where we had an initial version of our draft standards. We intended these standards to evolve, and ultimately we want the standards to become community maintained. So the next step was to gather community input for the standards. Now, rOpenSci has, as said at the start, a very large and active community. A very active Slack channel and a whole lot of other fora, including a discussion forum, which I didn't mention up there. We also have a discussion forum that's quite active. And so this large and active community was, for example, used or drawn on a lot throughout the development of standards. Here's a picture of one of our community calls, which have happened on Zoom since long before the whole world found out about Zoom due to a little glitch in the world around 2020. rOpenSci has always been a very Zoom-based organization since long before then, and we drew on the community for a lot of feedback throughout the development of these standards. There's another example of a Zoom community meeting happening in developing the standards. And we drew on a whole lot of different community channels to help us throughout this process. For the initial phases, it involved an awful lot of direct communication. And that got us to the stage where we had our draft standards, we had initial package submissions, and we still wanted to get more community feedback on standards. So now to finally get much more into the focus of the talk, community feedback on standards is a lot of work. So we tried a whole lot of different modes and ways of engaging and motivating communities. We did a lot of direct requests, emailing, messaging in other direct ways, a lot of indirect requests, messages sent out to smaller or larger groups of people, as well as what I've called their broadcast requests, and giving kind of vague indications of success over on the right there. Broadcast requests are, for example, what we have at the outset of our statistical dev guide here. I won't read the text there, but that's basically a plea for anybody at all to give us feedback at any stage about improving any of the standards. So this kind of broadcast messages are permeated throughout a lot of our materials to do with this statistical software program. And what that kind of built up in us as a mental model is this idea that we were far more likely to get responses to questions for feedback that were very, very, very specific. What we ideally would have liked would have been really general feedback about the whole program, or feedback encompassing sort of the interaction between the different forms of standards, or the more general feedback that we could get, the more use it was for us. But it was much easier to get much more specific feedback. So you've got sort of this negative relationship between the likelihood of a response and the generality of the response. There's nothing particularly amazing about this. It's simply the sort of or unique about this phenomenon. It's the process that the more you feel directly spoken to, the more likely that you'll respond. You can just change the word respond and understand how sort of universal this kind of process actually is. But what we needed to do was to figure out a way to change the slope of that relationship, to remove this sort of negative, strongly negative relationship. And so either make more general responses equally likely, or to make I've forgotten. Anyway, the point is that increasing the likelihood of responses, which is what politicians have to do when they're thinking about voting, is relatively easy, because there the responses are just binary. You do it or you don't do it. What we wanted was to increase the generality of responses. So you can increase the slope of that either by sort of stretching it out to the right or by lifting it up vertically. And we needed to focus on sort of the vertical lifting of somehow eliciting more general responses that were of more general use for us in improving the program in itself and improving the standards in particular. So these are the standards again in the 8 different categories that we have. The next slide is going to show subjectively the standards now weighted vaguely by sort of how comfortable I feel placing myself as an expert in these categories. So full disclosure, I'd probably wager that I could walk into somewhere and say I'm a reasonable expert on spatial statistical software. I'd be okay doing that. The further away I go from this sort of dark areas, the less comfortable I'd be doing that. And so it kind of suggests that if you replace likelihood of response by my personal comfort zone, then the relationship becomes positive. Uncomfortable for me to step out of that comfort zone, but that relationship itself then becomes quite positive. And there's a whole lot of interesting phenomena going on behind here, and one of the particularly interesting ones is kind of the notion of perception of expertise and what that means. So I'm judged as an expert in the domains in which I feel confident assuming that I'm judged as an expert, and that's where we got the best feedback. Really good, really general, encompassing feedback in spatial standards, in time series standards. And the areas in which I was far less comfortable, we got far less general feedback. And part of that process, I think really interestingly, is that as an expert, or no, in getting general feedback, or in maintaining, in passing these standards over to community maintenance, we want it to be a sort of iterative process. We want conversations themselves to be back and forth and back and forth. But the more degrees I am away from my comfort zone and my immediate network in which I'm recognized as an expert, the more likely any response is to be a one-off and not an iterative process. So these iterative kind of discussions themselves are best fostered by people being viewed as experts in an area. And there's all sorts of really interesting, complicated aspects with this process that if I knew at the time, we maybe would have done quite differently. Anyway, nearly at the conclusion now, the strategies for eliciting community feedback, other than extending beyond your comfort zone, are kind of to expand personal networks and cultivate personal networks beyond anything else, including networks beyond your networks, beyond your networks, beyond your networks. Also then to, rather than focus on individual people, but really focus small groups and probably organize workshops. We didn't really get to do this because it was 2020, 2021. It was very difficult to do a lot of this actual organizing of events and stuff like that. So that got us up to that stage. I haven't placed a tick on community feedback on standards because I'm still not convinced that we got the kind of feedback that we had aspired to get. And we're now at the stage where we want to pass over the standards somehow to community maintenance, ultimately, so that they become a community asset in themselves. Before I go on to the concluding slides in just a moment, I just want to express the gratitude to all of our editors. Here's some photos of a lot of them, as well as to all of our authors and reviewers, without whom this wouldn't exist. Also, we had an advisory board throughout the development of this whole project, to whom we are very, very grateful, Statistical Software Advisory Board. And with that, on to the final concluding comments, that active maintenance of anything, of rOpenSci itself, of JOS, requires actively seeking community support at all times. In passing these statistical software standards over to community maintenance, we are actively seeking community support right now, and so this talk is also a call for requests for any sort of support whatsoever that people might be able to offer, particularly keeping in mind you don't need to feel that you're an expert in the field to make an important and positive contribution to that field. So please contact us about helping to maintain, only slightly tongue-in-cheek there, the world's best standards for open source statistical software. World's best because they're the only ones that exist at the moment. With that, thank you very much.
Thank you. And while we're waiting for the questions to come up there, I'll read out my own first. I've seen in JOS that there was something about reproducibility in the checks, and I assume as you're working together that that's also part of rOpenSci. Are you collaborating with initiatives like ReproHack or CodeCheck or so who are working on software reproducibility or so on this, or how are you doing reproducibility checks?
Yes, we do. I don't think Anna's here, right? No, Anna Cristalli from ReproHack. She's closely involved with rOpenSci as well, so there's definitely strong connections there between ReproHack and rOpenSci. JOS, I once said, didn't have requirements for testing, or it had moderate requirements for testing. rOpenSci has very strict requirements for testing, much stricter. It has checks for being able to do full package installation, and we benefit particularly by a much narrower focus because we are based on R packages. They themselves have much more stringent tests. There's a standard array of tests run on an R package that all packages must pass, and those guarantee reproducibility. But then also within statistical software, we then made a whole extra set of standards about being able to what is reproducibility when you're talking about approximations and tolerances. And so every category has its own specific little standards for exactly what reproducibility is. But yeah.
Okay, thank you. How easy or relevant would it be to adapt your process to related contexts? For example, stat software handled by rOpenSci or Julia packages implementing mathematical methods?
Yes, that's a great question. And that was from Heather. Thank you very much, because that reminded me that I forgot to mention one of the very important things, that all of that reading that was done was completely language agnostic. It was just reading through software and through journal submissions about software from any language whatsoever. And there were areas like machine learning, obviously, where almost all of the input was in Python. And there were other areas where a lot of the input came from Julia. And then the standards were devised, and in a lot of the infrastructure and processes, in a way to be as language agnostic as possible. And the vision is ultimately for them to be then directly adaptable. Whether or not they're adapted depends on financing and all sorts of unknown things, but to rOpenSci as a first initial step beyond this as well. So we're still in ongoing conversations with rOpenSci, which I should have mentioned at the start as well, that rOpenSci is another organization for all those people there saying, well, great, but I don't care about R, but rOpenSci also uses the same infrastructure as well that both JOS and rOpenSci use. So we're all kind of in the same infrastructure umbrella as organizations. Yes, adaptability is inbuilt, and we're looking forward to having an opportunity to expand.
Great, thank you. And there's another question. Machine learning is a subcategory of statistical software in your context. Do you consider all machine learning software as statistical software, or does there exist machine learning software which is not statistical software?
Yes, of course there does. There exists a lot of machine learning software that's not statistical software. You'll have to excuse me, but you've seen there are 320 standards that I did write, but I don't remember the details of all of them. But there certainly are descriptions in the machine learning section that define exactly what we mean by machine learning statistical software, and it effectively comes down to producing statistical outputs. So yeah, there's a whole lot of machine learning aspects that are not statistical, and they're simply not under the umbrella of what we consider statistical software.
Okay, thank you. Another one has come in. Would you consider a partnership with the R journal or other journals that aren't JOS for submission of statistical software?
Yes, that's also a really good question. We do have a semi-official partnership with the Journal of Statistical Software, where initial review, once again, we encourage initial review at rOpenSci, and that will then be considered a pre-review for Journal of Statistical Software. So we already work directly with them to enable that process. The R Journal, we haven't had official conversations about a mode of entry there, but obviously we work quite closely together. And I imagine that'll simply be something that as soon as somebody wants to do that would be no problem at all to cross. But certainly Journal of Statistical Software, that track exists already.
Great, thank you very much. So that's, thank you. Thanks again to our speaker and to our previous speaker as well.